Okay, in today's section, we're going to cover consecutive integers. And we'll be able to show how this connects with the previous two sections as we go along through a couple of the examples today. So let's first off take a look at consecutive integers. Now remind yourselves, when we're talking about integers, that means numbers without decimals. So in today's assignment and in today's problems, we should not end up with decimals as answers. If we did, we're going to have to go back and check to make sure we're getting where we need to be. Once again, ignore the lines through here. The copy machine kind of put those there, but don't focus on those too much. All right, consecutive integers are numbers that follow each other in order with no gaps, increasing by 1 or 2. And we're going to define how we know it's one or the other in the next example. Now, when we're talking about consecutive integers, if we were to start with just any number like 6, the consecutive integers that start at 6 are going to be basically the next numbers on the number line as we move to the right. So if we think of 6, the next number that we would add, the next number that we would have would be 7 on the number line. Then after that we'd have 8, and after that we'd have 9, and after that we'd have 10. So basically what we're doing here is we're just adding 1 each time when it comes to consecutive integers. In case you're wondering, that's where we get the increase by 1. And like I said, on the next example, we'll show when we are going to increase by 2. So to give another example, let's say we had 30 as our starting point. If I wanted to give the next 3, if I wanted to give a total of 4 consecutive integers, we'd have 30, then we'd add 1 to that to give us 31, add 1 to that to give us 32, add 1 to that to give us 33, and there's our 4 consecutive integers. Now what we want to keep in mind is when we encounter negatives, okay? When we encounter negatives, we're still adding 1, moving right on the number line. Remember, with negatives, it's going in the opposite direction. So when we add 1 to -9, we're going to end up at -8. Add 1 to that to give us -7. Add 1 to that to give us -6. So just be wary of that when we come to negative numbers. We want to make sure we check ourselves when it comes to that. Okay? Take a look at the first example. There are several parts here. The one nice thing is the copier kind of put these lines on here. It does kind of separate my two main points here pretty nicely. So I'm going to use those to the advantage. I'll pause for a second in case you want to work ahead. Okay, let's take a look at these problems here. First one, we're going to give examples of the following. 3 consecutive integers starting with 13. Now since they're giving us a starting point, let's go ahead and use that starting point of 13. Okay? Now we want 3 consecutive integers. Once again, we're adding 1 each time. So 13, if we add 1 and go next on the number line, then we'd add 14. Add 1 to that one, the next on the number line would be 15. And that would actually be where we'd want to stop because we only needed 3 consecutive integers, 1, 2, and 3. Now remember, when we say consecutive integers, that means there's no other integers between 13 and 14 or 14 and 15. Now, the question is, what's going to happen when we do not know our starting point? So we start with the variable x. To be honest, the process doesn't change. We went from 13 to 14 by adding 1, and we keep on continuing this pattern by adding 1 each time. So if we start with x, well, we're going to simply add 1 to x to get the next term. Since we don't know it, that would simply be x plus 1. Now to go once again to the next term, we'd add another 1. Now we probably would look at that as x plus 1 plus 1, but we can go ahead and combine those plus 1s to where we'd have x plus 2. Okay, so to go from one term to the next, we add 1 each time. And we're always referencing back to our original variable x when we don't know it. And that is one that we want to look out for when we get down here to example 2. Now we see how we have this line right here. It just so happened that happened for me. It actually breaks these up into 2 main parts. Up here in these two, these were add 1, this was an add 1 each time because they did not contain one of 2 certain words. If we look at these next 4, each one of them has either even or odd in them. Anytime we're looking for consecutive integers and we're mainly want to be looking at even or odd consecutive integers, we are no longer going to be adding 1, but if we reference back to what I talked about here, we are instead going to be adding 2 each time. Okay? We're going to be adding 2 each time. Reason for that is if I want to talk about even numbers, if I add 2, well, let's take a look at it. We start with 44 in this problem, and we're told to find 4 consecutive even integers. If I add 2 to this, that'll give me 46. Add 2 to that one, that'll give me 48. Add 2 to that one, that'll give me 50. So I have 4 consecutive even integers. Now, the reason why we add 2 is because we have 45 in between here, and yes, that is an integer, but it's not an even integer. So in order to list the even integers here, we have to add 2. That adding 2 will skip over the 45 in the middle and go directly to the 46. Adding 2 to this one will skip over the 47 to get to the 48, and then adding 2 to this one will skip over the 49 to get to the 50. So once again, when we see even or odd in these problems, we're adding 2 each time instead of adding 1. If we were to look at the next one here, 5 consecutive odd integers starting with 11, okay, and continue that pattern by adding 2 each time, we go from 11 to 13, add 2 to that one to give us 15, add 2 to that one to give us 17, add 2 to that one to give us 19, and really we could keep going, but we only need however many they asked for. They asked for 5 consecutive odd integers. All right, the next one, we have a -9 as our starting point. So this one's going to be a little bit different, but the process is still the same. 3 consecutive odd integers. We're still, since we see that term odd, we're going to be adding 2 each time. Now keep in mind, -9 plus 2 moves to the right on the number line, so we're going to end up with a -7 there. And then if we add 2 to that one, we'd end up with -5. Okay, and those would be our 3 consecutive odd terms there. This last one is another one we want to start off because it's going to be an important one in examples 3 and 4. Once again, we have the same starting point as we did up here by starting with x. But instead of the consecutive integers where we added 1 each time, we're now wanting the consecutive even integers. So once again, instead of adding by 1 each time, we're going to add by 2. So we'll take our original term x, add 2 to that, and then we'll continue the pattern, add 2 more to give us x plus 4, and continue it to give us x plus 6. So we have 1, 2, 3, 4 consecutive even integers. Now this would have been the exact same thing we would have started with if this would have said 4 consecutive odd integers. Okay? Just because it's even or odd doesn't mean that these are going to change here with the variable, okay, when we start with an x. All right? And this is going to be what we use for examples 3 and 4, but we're going to use this x, x plus 1, and x plus 2 for example 2 here. Now this problem here states the sum of 3 consecutive integers is 129. We want to determine what those 3 integers are. First things first, we want to determine, are we going to be adding 1 each time or are we going to be adding 2? We do not see anywhere in here where it's stating odd or even. So since it is not stating odd or even, we're going to know that this is going to be a +1 each time. Okay? And since we do not know the starting point, our starting point is going to be our variable x. Okay? Now, we want to write 3 terms here. This is the first one. The next one, we're going to apply what we're doing each time. So it'd be x. The next term would be x plus 1. If we add 1 to this one, we'd have x plus 2. So we have 3 consecutive integers. Now, what it says we want to do up here is we want to find, they tell us that the sum of these 3 is 129. So we are going to add them all together and set that equal to 129. Now, this is a problem very similar from back yesterday when we talked about perimeter and geometry application. By combining like terms, we're going to simplify this down a little bit. So we try to count how many x's that we have. We have 1x, 1x, 1x. If we add those like terms together, we're going to get 3x. And then if we focus on the constants, 1 and 2, add those together, it's also going to give us a 3. And this is all still equal to 129, which we arrive at a problem which is very similar to the first day of notes of 1.2 that we took, dealing with solving linear equations. We want to get the variable by itself. And once again, in order to get the variable by itself, we have to do opposite PEMDAS. So before we get rid of the multiplication, we got to get rid of the addition. So we're going to subtract 3 from both sides. Those 3's on the left are going to cancel out, leaving us with 3x is equal to 129 minus 3, which is 126. And then after we get done with that part, we are going to get rid of the times 3 by dividing by 3. 3's on the left cancel out, leaving us with x is equal to 42. Now, this isn't our final answer, but it actually is part of our answer. This is the first consecutive integer that we're dealing with in this one. This is the x. But keep in mind, we have x. We also need to find x plus 1. We also need to find x plus 2. Okay? So if we plug it in, for x is equal to 42, we plug that straight in. If I plug it in for this one, that'll give me 42 plus 1, which is 43. And if I plug in x is 42 for this one, that'll give me 42 plus 2, which is equal to 44. So our three consecutive integers would be 42, 43, and 44 for this problem. Now, I want to make sure we don't make the mistake here of some students might think that the answer is 42, 43, 45, because what they did was they plugged in 42 for x for the first one. Then they would plug in 42 for this one, so they do 42 plus 1 is equal to 43. Then they would make the mistake, though. They would take this 43 and plug it in down here and do 43 plus 2. Keep in mind, this is x. So we want to always revert back to the original x. So we want to take 42, add 1 to get the second term, take 42 and add 2 to it to get the third term. Okay? And once again, one quick way we can make sure that this is the correct answer. Once, do we have three consecutive integers? Which we do. If we were to add all three of them together, what would we get? We would actually get 129 here. So these are our three consecutive integers. Okay? All right, let's take a look at this one. Go and give you a second here if you want to work through it and read through. Okay. The sum of three consecutive odd integers is 75. Determine the three integers. So almost everything is the same in this problem, except we notice the fact that we have the word odd. That means anytime we see odd or even in a problem, instead of adding 1, we're going to be adding 2 in this one. So we're still dealing with three consecutive integers. So we'll start off with x. Okay. Then we're going to move to the next term, which would be not instead of plus 1 this time, we have that odd. This is going to be x plus 2. And then we add 2 more to that to get the next one, which would be x plus 3. And here are our three terms. Now in this problem, they say that they add together to give us 75. So we're just going to add them together and set them equal to 75. And now we're in the same boat as combining like terms like we did yesterday. So we want to add all the x's together. They give us 3x, which, to give you a heads up, you're always going to have your number of x's that you have here will always be how many terms you're trying to find. So you shouldn't be ending up with 4x, 5x, 2x, or 1x in this problem, because we should be ending up with three consecutive terms. We should have 3x. Just to give you a little hint, try to help you out for future reference. Now let's go ahead and add 2 and 3 together here. Which actually, this is going to be an error on my part because, well, things like this happen. Luckily enough for us, we were able to catch it right now. We're trying to find the three consecutive odd integers being set, and they add up to be 75. So we're supposed to be adding 2 each time. If you take a look, we go from x to x plus 2, we did add 2. But unfortunately, luckily I caught it right here, to go from this term to this term, we're not adding 2, we only added 1 to it. So I want to make sure, oh boy, we fix that real quick. That should be an x plus 4. My apologies for that. But the good thing is we were able to take a look at that real quick and see that we made a mistake. So we add 2 and 4 together. That's going to give us a plus 6 is equal to 75. Okay? Now let's hope we can get through this one with no more hiccups. Now, we have to solve for x here, so we're going to get rid of the plus 6 by subtracting 6 from both sides. So the 6's are going to go away. On the left side, leaving us with 3x is equal to 69. And we want to get rid of the times 3 by dividing 3 on both sides. 3's on the left are going to cancel out, leaving us with x is equal to 23. Now keep in mind, one also thing we always look out for, this is an even number. If we end up with an odd number for this problem, or sorry, this is an odd number. I mean, I did that again. I'll focus up here in a second. I'm just going to take a breather. And anytime that you're doing notes here and you kind of get flustered, just take a breather real quick and let's arrive back at the problem. This is an odd number. If I would have ended up with an even number right here, I know I had a mistake because I'm supposed to be ending up with odd numbers and this is supposed to be my first one. Also, another thing we look for, if we end up with a decimal here, it's no longer an integer. So this one, we know we're good, but just always make sure we're looking out for those little hiccups that we might have. So once again, the first term was x, the next term was x plus 2, and the final term on this one, after the correction, was x plus 4. Now, we want to substitute x in, so we're going to substitute 23. For this one, we take 23, we'll add 2 to it to give us 25. For this one, we'll add 23 to 4 to give us 27. Now we have 3 consecutive odd integers whose sum, if we were to add all 3 of these together, would give us 75. That was a little bit of a rough one for myself, so luckily we were able to catch that mistake, and luckily we were able to fix what I said right there. But we still arrived at the same answer, and we always check our work by adding all 3 of these together to make sure not only do we end up with 75, but to make sure that it's still staying true to what it says up here, 3 consecutive odd integers. All right, let's see how example 4 goes right here. Hopefully we can redeem ourselves and go through this without a hitch. Let's see what we have here. The sum of 3 consecutive even integers is 378. Determine the 3 integers. Doesn't matter if this is a bigger number, smaller number, negative number, positive number. The process is still going to be the same. First things first, do we have the word even or odd? We do, which means we're going to have plus 2 on this one. We're going to have to skip over the odds so we can just have the evens. Since we don't know the starting point, it's going to be an x. And we want 3 consecutive terms again. So once again, counting by 2s, we'd have x, then x plus 2, then x plus 4. The sum of those is going to be 378, so let's add all those together. So we end up with 378. And let's combine like terms. X, 1, 2, and 3x is there. So we have 3x. Combine our numbers together, our constants. We have plus 6 is equal to 378. Now, if you recognize this 3x plus 6, we actually had it on the previous problem when we were dealing with 3 consecutive odd integers. Now, this one we're dealing with 3 consecutive even integers. The equation doesn't change, just the sum number and what our integers end up being. So that's kind of nice to know that we're doing this process correctly. Next, we want to get rid of the plus 6 through opposite order of operations and golden rule by doing everything to both sides. 6's on the left cancel out, leaving us with 3x is equal to 372. And then after we do that, we're going to get rid of this times 3 by dividing both sides by 3, in which case we'll end up with x is equal to 124. Our first integer of our 3 consecutive evens. So let's find what those others are real quick. We have x, x plus 2, and x plus 4 is equal to, the first one's just going to be what our x is, 124. Add 2 to that to give us 126. Add 4 to the original one, so we have 124 plus 4. They give us 128. 3 consecutive even integers who add up, or whose sum is 378. Okay? That one went a little bit smoother than the third problem. But once again, anytime that we encounter that we did something wrong, always just go back and check our work. If we need to take a breather at any point, we should do so. Okay? We don't want this to be a stressful situation. We just want to make sure that we're increasing our overall comprehension of the material. Okay. That will conclude the notes over this section. You need to complete the assignment that is attached with this lesson. And once again, if you have any questions, just send me an email.